Hello everyone, welcome back to another video of my YouTube channel. Today we'll be doing another question from the blind 75 list of problems, and this question is named to sum. So in this question we are given an array and we are supposed to find two indices in the array such that the numbers on those indices sum up to the target value which we are given. For example, we are given the array 2, 7, 11, 15 and the target number is 9. That means we need to find two numbers in this array which sum up to 9. So for example, 2 plus 7 is 9. So 0 and first index. So I will return 0 and 1 in an array as the answer. Same for the second example. I want to find two indices that sum up to 6. So 2 and 4 sum up to 6 because 2 plus 4 is 6, and the indices are 1 and 2 in this case. So I'll return 1 and 2 as the answer. Now the brute force approach to solve this problem would be to consider all the pairs in the array. So for example, in this first example, start with the first index 2 and go through each other number. So for example, 2, 7, 2, 11, 2, 15, and see if we get 9 anytime. So we get it in the first pass. First index is 2 and 2 plus 7 is 9. So we just return 0, 1 in that case. In this case, I start with 3, 3, 2, 3, 4. None of them sum up to 6. Then I move on to the next index 2 and 2, 4 sum up to 6. So I'll return the answer 1, 2. Now, what would be the time complexity of this brute force approach? It would be O of n square, as we are considering all the pairs. And the space complexity in this case would be O of 1, as we are not using any extra space while calculating all the pairs in the array. Now, can we improve this time complexity somehow? Now what can we do is use something called a hash map. And what is a hash map is that it contains key value pairs in a table. You can consider it to be a table which has key value pairs, and you can do insertion and lookup in this table in O of 1 time. This is the average time complexity. So you can consider it similar to a hash set which we discussed earlier. The only difference is that it stores key value pairs and not a single value. So you need to query by the keys and you will get the corresponding value. Okay, so we'll now use this hash map to solve our problem. So let's start. So I'll insert values into this hash map moving left to right. So let's start for 2, 7, 11 and 15. If we come to 2, we insert it into the hash map, and as we need the indices and not the value, so the key will be the value and the key will be the value in the array, and the value in the hash map will be the index. So for example, I'll insert for 2, I'll insert 2 comma 0 as it is the 0th index. Okay, now as I move in the array, I'll check if I already have the target minus current value in the hash map. Okay, so I move to 7. I check if 9 minus 7, which is 2, is already there in the hash map or not, and it is already present. So what I do is I'll return the value from the hash map. So consider this hash map name is m. So m of target minus ai, and which is the current value I. So this will be our answer. Now let's see it for the second example to get it more clearly. Just give me a moment to remove these. Okay, I have this hash map and I'm given the array 3 to 4 and the target is 6. Okay, I start with 3, target minus 3, 6 minus 3, 3 is not already there, so I insert 3, 3 comma 0. Move on to the next value 2, 6 minus 2, 4 is not there already in the hash map, so I insert the current value which is 2 and it index 1. Then move on to the next value 4 and check if 6 minus 4, 2 is there already in the hash map or not. 2 is already there, so I'll take 2 from the hash map, 2's index from the hash map, sorry. So m of 2, which would be 1 in this case, 1 comma the current index which we are at, which is this one. So it will be 1 comma 2, which is 2 and 4. 2 plus 4 is 6. I hope you got that. Now let's move on to coding this solution. And before we move to that, let's also find the time and space complexity for this approach. So the time complexity of this approach would be O of n. As we are moving over the array and doing only insertion and queries, which is O of 1 time in average. Okay, so that is why it will be O of n, and the space complexity would be O of n, as we are storing at max n numbers in the hash map. Okay, now let's code this out. We are given a function called toSum, and the input is given as a vector called nums and an integer called target. Now what we discussed doing is that using a hash map, which is called an unordered map in C++, which will be key value pairs of type int, int, and let's name it m. Now I'll go through all the numbers in the input vector and I'll check if the hash map has target minus the current number. Okay, I can't use this auto range mapping because I'll also need the index. So let's use a normal loop here. So for int I equals to 0, I less than nums dot size and I plus plus space for target minus nums I. Okay, if the hash map has this, so this means that we have this value in the hash map. In that case, we just return a new vector with values m of target minus nums I, which will be the index of the found value and the current index. But if it is not found, we just insert it into the hash map, which we would do like m of nums I, and the value of this would be I. Okay, that looks fine to me. In case no answer is found, just for safety, we'll return -1. Let's try running it. Okay, so all 3 test cases worked as expected. Now let's try submitting it. So as you can see, it worked as expected, and I hope you enjoyed this video. Do like, share and subscribe. Thank you for watching. Happy coding.